Okay, hello students. Today we discuss about the periodic table. In periodic table we discuss about ionic radius. Ionic radius. Radius means distance from nucleus to outermost electron. In an atom, nucleus is there, that distance to outermost valence shell electron, that distance is known as radius of an atom. So that is known as atomic radius. This radius is of three types: covalent radius, metallic radius, and van der Waals or inert gas radius. First one, that is covalent radius. If in an atom, if it is bonded by covalent bond means sharing of electron. Suppose A atom react with B and forms the sharing of electron, then it is known as covalent bond. Then distance from center to this covalent bond share electron, or you find the distance between the two nuclei and you make it half, and that radius is known as covalent radius. Second is the metallic radius. If iron is there, Fe, then distance between two nuclei, you make it half, then it will give the radius in metallic bond. As for example, iron and copper. So that radius is known as metallic radius. Next, third one, that is van der Waals radius. In inert gas, if both element or both atom is same, suppose it is chlorine, and distance between these two, that is the diameter. This divided by 2, that will give the radius. That radius is known as van der Waals radius, or it is of inert gas radius. So these are the radius. In periodic table, how these radius can be calculated in periodic table? As you know that if atomic number increases, then electron increases, but its proton also increases. So attractive force also is increases. So in a periodic table, what will be the trend of this radius? That we discuss one by one. Suppose we take in the group. Okay, we goes in the group. Group means groups and period we will discuss. Suppose we take the periodic table. Then these are the first, second, third, fourth up to 7 periods are there. These are the periods and these are the groups. Total 1 to 18 groups are there. Here 13 to this is P block, 1 and 2 is S block. In the middle it is D block and F block. So variation in groups. So from top to bottom, if you move in the periodic table, top to bottom, first group, second group, 13 to 18. If you go top to bottom in a groups, then electrons are added in the outermost orbit. So radius is increases. Okay, radius is increased. Suppose this 13 radius it is of this much size, then second radius is increased, third radius is increased, third radius is increased. So if you go down in a particular group, radius is increases as atomic number increases. Second, variation in period. Any period you can select, first, second, third. If you move from left side to right side, this is left side, this is right side, atomic number increases. Electrons are added in same outermost orbit, same circle. Then this radius is like this. Second, electron is also added and proton is also in the same circle. If same circle electron is added, then radius will sink. So there is decrease in the radius. You can see there is decrease in the radius. So radius, if you move from left to right side, radius decreases. Similarly from top to bottom also radius decreases. In the book graph is given. Suppose you draw the graph of radius against atomic number. Suppose first we go in the group. Okay, if you move from top to bottom, then this graph will goes in a straight line. It is increases. Similarly, in groups it is. Similarly, in period, if you move, then there is decrease in the radius take place. So this is about atomic radius. Again I revise, covalent radius is there, metallic radius is there, and van der Waals radius is there. And remember this thing in group. Okay, again I revise, in group. Group means 1, 2. Suppose we take alkali metal, alkaline earth metal, alkali metal. Okay, lithium, sodium, potassium, rubidium, cesium, lithium, okay, rubidium, cesium. These elements, when we go down, then its radius increases. Second, calcium, magnesium, strontium, barium, radium, radius is increases. In 13 group, boron, aluminium, gallium, indium, thallium. 15 group, nitrogen, phosphorus, arsenic, antimony, bismuth. So this radius is increases. In this way, in D block elements or F block elements, if you move, then screening effect will increases. Because of this screening effect, its radius is decreases. In the D block, there is slight increase and decrease in the radius. There is slight decrease in the radius as compared to P block and D block. Radius is increasing or decrease in more amount, but in D and F block, all radius are almost same. There is slight increase decrease in. Now second topic that we discuss, that is ionization enthalpy. Ionization enthalpy. Okay, ionization energy or ionization enthalpy. Suppose you take one atom A and remove one electron from that neutral atom and convert it into ions A plus. Then amount of energy to require this 1 mole of electron from 1 mole of neutral atom, that energy is known as ionization energy, or it is known as ionization enthalpy, IE. Again, if you take A plus 1, okay, A plus 1, again if second electron is removed from this, then A plus is converted to A plus 2. So second electron will, that is known as second ionization enthalpy. Similarly, A plus 2 is converted to A plus 3. If you remove again one electron from, similarly directly you remove 3 electrons from A, then A is converted to plus 3 directly. But one by one, if you remove the electron, then energy required for this reaction, that is known as ionization enthalpy. Its symbol is delta H. Ionization enthalpy, that is delta H for the reaction. Here we discuss this ionization enthalpy in terms of radius in periodic table. Again, in periodic table, if you move in a group, means from top to bottom, its radius is increases. Radius, if it is increases, then it is very easy to remove electron from the outermost orbit. So new rule comes that ionization enthalpy is inversely proportional to radius. Ionization enthalpy is inversely proportional to radius. Remember this. Okay, if you move down the group, then radius is increases. So ionization enthalpy is less. If you move here to here, then its radius is decreases. So ionization enthalpy, if you move from left to right side in a particular period, then ionization enthalpy will increases. Okay, ionization enthalpy will increases. Second, about radius of the ions. If you discuss this, then radius of the ion we will discuss. If A atom is there, its electron is removed, then its radius will what? If you remove electron, then radius will decrease. So here you can see A atom radius is greater than A plus 1, is greater than A plus 2, is greater than A plus 3. Okay, radius of neutral atom is more as compared to ions. So ionic radius is always less. Remember this. Second thing about ionization enthalpy. We compare radius with ionization enthalpy. Ionization enthalpy, again I revise the definition, amount of energy required to take out electron from an atom or ion, that is known as ionization enthalpy. Here radius is decreases, so ionization enthalpy increases. Ionization enthalpy increases for particular ion. Radius decreases, then ionization enthalpy, as per this rule, ionization enthalpy is inversely proportional to radius. Radius decreases, then ionization enthalpy increases, or radius increases, then ionization enthalpy decreases. And ionic radius is always less than that of neutral atom. So remember this. Next time we discuss about the electronegativity. Electronegativity or electron gain enthalpy. Okay, second topic after this, that is electronegativity. In that you have to add electron, and electron gain enthalpy. Remember this. This is ionization enthalpy, and then it's electron gain enthalpy. Next chapter we will discuss about that two particular topic. Okay, try to draw the graph related with the ionization enthalpy and radius as given in your text. Okay, thank you.